the most distant human-made explorers ever launched, are still communicating with Earth. More than 4 decades after leaving our planet, long after engineers expected them to fall silent forever, faint radio signals continue arriving from the darkness beyond our solar system. These signals travel across unimaginable distances, growing weaker every hour as they cross billions of miles of empty space. Delayed by more than 16 hours, fragile and barely detectable, they are whispers from the edge of the known universe. Recently, one of those whispers carried something unexpected. For months, scientists monitoring the NASA Deep Space Network had become increasingly worried. Signals arriving from deep space were behaving strangely. Data streams that once delivered precise scientific measurements had degraded into fragments and digital noise. Information appeared incomplete, scrambled, and difficult to interpret. Many feared the worst. After all, the spacecraft responsible for these transmissions were never designed to survive this long. Built using 1970s technology, the twin Voyager probes were expected to function for only a few years. Instead, they have continued operating for nearly half a century. Their systems are aging. Their memory is tiny by modern standards. Their power supply slowly fades every year. Yet somehow, they continue. Then, without warning, something changed. A faint tremor passed through Earth's listening systems as a signal arrived from more than 12 billion miles away. Weak and ghost-like after its enormous journey through space, the transmission carried something scientists had been hoping for. The spacecraft had regained its voice. The probe sending the signal was Voyager 2, launched in 1977. Voyager 2 originally began its mission exploring the outer planets of our solar system. It captured historic close-up images of Jupiter, Saturn, Uranus, Neptune. No spacecraft before or since has visited all 4 giant outer planets in a single mission. But Voyager 2's journey did not end there. Using gravitational assists from the planets, the spacecraft gained enough speed to continue outward into the darkness beyond the solar system itself. Guided only by faint commands sent from Earth, Voyager 2 kept traveling farther than anyone originally imagined possible. Today, it moves through interstellar space, a region no human-made object was ever expected to reach during its operational lifetime. Hardened by decades of radiation, freezing temperatures, and complete isolation, the spacecraft continues functioning far beyond its intended lifespan. But this time, the data Voyager 2 returned was more than proof of survival. Hidden inside those faint transmissions were measurements that did not match existing scientific predictions about the edge of our solar system. For decades, astronomers believed the outer boundary of the solar system was relatively simple. The Sun constantly releases a stream of charged particles called the solar wind. This flow expands outward in every direction, creating a gigantic protective bubble surrounding the planets. This enormous bubble is known as the heliosphere. At its outer edge lies a boundary where the solar wind weakens against the pressure of interstellar space. Scientists call this boundary the heliopause. Originally, researchers imagined this frontier as smooth and stable, a quiet border separating our solar system from the wider galaxy. But Voyager 2 revealed something very different. Instead of crossing a clean edge, the spacecraft appeared to be moving through a turbulent layered region filled with magnetic distortions, shifting plasma densities, strange particle flows, unexpected structures. Months before communications were fully restored, Voyager 2's instruments had already begun detecting anomalies. Its plasma wave detector recorded vibrations at frequencies scientists did not expect to find so far from the Sun. At the same time, the spacecraft's magnetometer traced unusually organized magnetic patterns, structures that appeared too ordered to be random turbulence. Even the cosmic ray detectors measured rhythmic variations rather than chaotic fluctuations. At first, scientists suspected equipment failure. After all, Voyager 2 is operating far beyond its original design limits. But after recalibration and comparison with data from its twin spacecraft, Voyager 1, the conclusion became unavoidable. The readings were real. Voyager 2 was not malfunctioning. It was discovering something entirely new. The data returned by Voyager 2 revealed a startling possibility. The outer boundary of the solar system is not a simple barrier. It is dynamic, changing, and alive with activity. Instead of behaving like a smooth bubble surrounding the Sun, the heliosphere appears filled with folds, ridges, and layered magnetic regions. Scientists now believe the spacecraft may be traveling through what can best be described as magnetic islands, compartments in space where conditions change dramatically from one region to another. Each region appears to contain different magnetic orientations, different particle densities, different energy levels, different plasma flows. The result is a frontier that behaves less like a wall and more like a living membrane. This discovery suggests something even more profound. Our solar system is not isolated. It constantly interacts with the galaxy surrounding it. Massive waves moving through interstellar space, generated by ancient supernova explosions and powerful stellar winds, may compress and stretch the heliosphere over time. These disturbances travel across trillions of miles and could explain why Voyager 2 detects repeating fluctuations in magnetic fields and particle densities. In some regions, the heliosphere appears stronger, shielding the solar system from dangerous cosmic rays. In other regions, it weakens, allowing energetic particles from deep space to move closer toward the Sun. This means the protective shield surrounding our solar system is not constant. It changes. In a sense, it breathes. Voyager 2 also recorded sudden reversals in magnetic field direction. These changes were too abrupt to be explained by ordinary turbulence. Scientists believe they may be witnessing a process known as magnetic reconnection, an event where magnetic field lines snap apart and reconnect, releasing bursts of energy. Such events are common near the Sun. Detecting them near the edge of the solar system suggests that the boundary between our solar system and the galaxy is far more active than scientists once imagined. The spacecraft also detected plasma oscillations, wave-like vibrations moving through this layered frontier. These oscillations suggest that the heliopause may support resonances, allowing certain frequencies to travel through it almost like sound moving across a stretched surface. Particles appear to accelerate along narrow magnetic channels, following invisible pathways shaped by surrounding magnetic fields. Temperatures fluctuate sharply between nearby regions, hinting at localized heating caused by magnetic turbulence and particle acceleration. Taken together, these discoveries completely change our understanding of interstellar space. It is not empty. It is not silent. It is a dynamic environment filled with charged particles, magnetic currents, plasma waves, high-energy radiation, interstellar dust. Beyond the heliosphere, Voyager 2 has also measured increased numbers of neutral hydrogen and helium atoms drifting through interstellar space. These particles may carry information about ancient stellar events that occurred long before our solar system formed. Even microscopic dust grains colliding with the spacecraft offer clues about energetic processes shaping the galaxy. Scientists now compare the galaxy to a vast cosmic ocean, filled with invisible currents, magnetic storms, and flowing structures. And Voyager 2 is sailing directly through it. Every signal it sends takes more than 16 hours to reach Earth. Yet every faint transmission expands humanity's understanding of its place within the Milky Way galaxy. What once seemed like the quiet edge of our cosmic neighborhood now appears to be something entirely different. A living frontier where the influence of the Sun collides with the forces of the galaxy itself. And as Voyager 2 drifts deeper into interstellar darkness, it continues revealing a profound truth. The universe is far more structured, active, and mysterious than we once believed. The edge of the solar system was never the end. It was only the beginning.